Hello, welcome back. So we're going to continue on in this lesson with the power rule. So the power rule for the antiderivative, remember, is just the opposite of a derivative, where we are going to add one to the power and then we're going to divide by that new power. We can call it add, divide, and conquer. Okay, so for a problem like this one, now notice we have to do it twice. So for this example, I'm going to kind of show you what's really going on, and then we'll never really do it this way again. For this one, we can split the integral. We would get x cubed dx. Because remember, our rule says we can split. I can split an integral. Plus, this would be the integral of 3x dx. What I could do now is I can apply the power rule to both of these separately. And remember, we're not going to do this ever again. In the future, we're just going to do this all a little bit quicker. So my rule says I can add 1 to the power, so this is going to become x cubed plus 1 over 3 plus 1 plus, now over here, now note, we're supposed to put a plus c, but we'll talk about that in a minute. Over here, I'm going to do the same thing. I'm going to get this 3x. Now there is a 1 there, so it's kind of like there's a 1 there, so when I add 1, we're going to get 1 plus 1. And I'm going to divide by that 1 plus 1. And this would also have a constant. Since they both have a constant to them, I'm really only going to add one constant to it. Makes it a little bit easier for us. So our final answer is just going to become this. X to the 4th over 4 plus 3x squared over 2 plus c1. And you can check to see if this works by taking the derivative. Here we would get the 4 would cancel with this 4. We would get x cubed. Drop the power of 2, we would cancel here, and we would get 3x. And the c, don't forget, the c is my constant of integration. We want to make sure we have that. And it just would go away when we took the derivative. So we want to make sure we don't forget this. Okay, don't forget that. We need to have it there. All right, so and we're not going to really split them up all the time because that just takes a while to do, and we want to go through these pretty quickly. So if we take a look at example like number 3 here, the first thing I'm going to do is I'm going to rewrite some things. I don't like 4 to the root x, so I could write this as 4x to the 1/2 plus 3 dx. And now I can do my work. For here, I'm going to get 4x to the 1/2 plus 1. And if you're really good with math, you know 1/2 plus 1 is just 3/2. So just leave it like this if you want to. Plus 3. Now the 3 here doesn't have an x. So we're going to go back up to our rule here, our constant rule. Our constant rule from an earlier video said we're just going to add an x to it. So another way to look at it is you can kind of think of this as x to the 0. So this would be x to the 0 plus 1. Over 0 plus 1 plus c1. And there's our answer. So when we write our final answers, we would get the following. 4x 1/2 plus 1 is 3/2 over 3/2. We're going to talk about this. We really don't like that. Plus, this is just 3x to the 1st over 1 plus our constant of integration. Now, again, we have a complex fraction here. So I'm just going to multiply both top and bottom by 2 to get rid of that fraction down there. And that's now going to give us 8/3 x to the 3/2 plus 3x, you don't have to put the 1 there, plus c1. And there's our final answer right here. For number 4, same thing. I'm going to rewrite it. I don't like this. I don't like this 2x to negative 2. So I'm going to write it as 8x cubed plus 1/2, and I'm just going to bring my x up. Don't bring the 2 up, just bring the x up. But we're going to make it a negative 2. And now we can apply our power rule. Ready? Let's go a little faster. We're going to add 1 to 3, so we're going to get 8x to the 4th. But because I'm adding 1, remember I'm going to divide by 4, plus, this is just 1/2 x, add 1, I get negative 1. But remember, I'm going to divide by that negative 1 as well, plus my constant of integration. And so our final answer, we just get 2x to the 4th. Now I can bring out the minus here. This becomes minus 1 over 2. And then x to the negative 1, remember, this is just going to go on bottom. So I'm going to write it over x, 1 over 2x. Remember, leave the 1/2 already on the bottom. I don't bring that 2 up. And then don't forget your constant of integration. And there is the OG, or the original function, 2x to the 4th minus 1 over 2x plus our constant. Let's try number 5 real quick. This is okay. This is just, if I were to rewrite it, it's just 1/4 x cubed plus, again, I don't like this x squared on bottom, so I'm going to bring it up, x to the negative 2 dx. Don't forget to rewrite your dx's as well. I know I haven't mentioned that before, but we talked about in our first video just how important that dx comes from. It is our differential. It's saying that this right here is a derivative. So this dx is really telling us that this right here is a derivative, and we want to find the original function. So our rule, very simple. We're going to add 1 here. So plus 1 to 3. Plus 1, there we go. We get 1/4 x to the 4th, and we're going to put that over 4, divide that by 4, because we're going to divide by the new power, plus, and again we're going to add 1 here. This becomes x to the negative 1 over negative 1. And then the last thing we need to add is our constant of integration. I can clean this up. This is 1 over 16 x to the 4th minus, because we're changing our signs here, 1 over x. We don't like that x to the negative 1 plus our constant of integration. And there is our antiderivative, or the integral, if you want to call it. Now, I got some good news for you. There is no quotient rule, really, in this. There is something we call the, oh my gosh, I forget which rule it is. Anyways, but there is no quotient rule directly. So that creates a problem for us. For a question like number 6, we must get creative. And for this one is, I am going to split the integral. I can do that because I'm dividing by a single term. And if I divide by a single term, I can rewrite this as x squared over x to the 1/2 plus 2x over x to the 1/2 minus 3 over x to the 1/2 dx. And the reason I like this is because now I can simplify this. I can't do the power rule as it. I just can't do the power on top, power on bottom, because this is division. And like we did when we did derivatives, it's just not as easy as taking the derivative top and bottom. So I can now rewrite this by subtracting my powers. This just becomes x to the 3/2, because 2 minus 1/2 is 3/2. Plus, remember there's a 1 here. 1 minus 1/2, that's just x to the 1/2. Minus 3, and again, I don't like this x on bottom. I'm going to bring my x up. We get x to the negative 1/2 dx. And now I can apply my rule. You're going to get really good with fractions here. So for our first one, we're going to add 1. This becomes x to the 5/2 times over 5/2, over 5/2, plus x, add 1 here. We get 3/2 over 3/2 minus 3x, and here I'm going to add 1. Negative 1/2 plus 1 is 1/2 over 1/2 plus c1. And notice, these are all complex fractions, which we don't like, so I'm going to multiply top and bottom here by 2. Those cancel. And I'm left with 2 over 5, x to the 5/2, plus multiply top and bottom here by 2, and I get 2/3 x to the 3/2, minus multiply top and bottom here by 2, and I just get 6x to the 1/2 plus our constant of integration. Ooh, ran out of room there, definitely. Another way to do it is we're just inverting and multiplying. I'm just going to take this 5/2 and divide it by 5/2, which means it's going to become 2/5. Very easy to do. The more you know about algebra, the easier it's going to become for us. So be careful. Split the integral there. Number 7. Oh no. The scary one. Oh no. Theta. People panic about theta. Remember, don't panic. We're integrating with respect to theta. This is just a variable. It's like x. So when I integrate this one, same thing. My rule says add 1. So I'm going to get 2 theta cubed over 3 plus, over here I'm going to add 1. This is, remember, there's a 1 there, so plus 1. So this becomes 3 theta squared over 2 plus, now remember, this 1, there is no theta. Therefore, we just add 1 to it. So this just becomes plus 1 theta plus your constant of integration. Very easy to do. So again, and for the next one, just like quotient rule, there is no product rule as well. So again, that kind of creates a problem. For example, like if we take a look at number 8 here, we want to integrate 2t plus 3 squared. Now there's another one, we're going to talk about this later on, called use substitution, but we're not ready for that yet. We're not quite old enough for that. So for this one, what we're going to have to do is we are going to have to expand. Take 2t plus 3 times 2t plus 3, and that's going to give us 4t squared plus 12t plus 9. And that's my new antiderivative. And we just use our rule. We're going to do it 3 times. We got 3 terms there. My first one, again, just add 1. We get 4t cubed over 3 plus 12. Well, there's a 1 there, so I add 1. So we get 12t squared over 2 plus, now remember, this is my constant rule. My constant rule says to just add 1 variable. It's really saying 9t to the 0. So if I add 1, I'm literally just adding 1 variable there. We'll talk, like this is like saying t to the 0 times t to the first. So we're really just adding 1t right there. So this becomes just 9t. And now at the very end, please don't forget the plus c1. You can reduce that to 6 if you feel like it. Okay? All right. So let's go into a couple more here. Do a few more. Number 9, this is where the fun really begins right here. So for a problem like number 9, I'm going to rewrite this again. I'm going to rewrite this as 1 over x times x to the 1/2 dx. And by doing such, well, I can now add their exponents together. There's a 1 there, and this becomes now 1 over x to the 3/2 dx. 1 plus 1/2 is 3/2. I still can't integrate it, because remember, there is no quotient rule here. So I have to use my power rule, which means I'm going to bring this term up. And my new integral just becomes x to the negative 3/2 dx. And once I'm here, now I can integrate using our power rule. Which means now I'm ready to integrate, so I'm going to add 1. Well, what's negative 3/2 plus 1? Yeah, it's just x to the negative 1/2. But remember, you have to divide by that negative 1/2 and add your constant of integration. This homework is so easy. All I'm really looking for is that plus c. Did you remember it? Now, I'm going to invert and multiply, so this becomes negative 2. But remember, I don't like a negative exponent, so I flip it. This is 1 over x to the 1/2 plus c1. And there's our antiderivative right there. That's kind of a nasty little one right there. For number 10, again, remember there's no product rule, so we're just going to expand this one. And when we do that, we're going to get 2x squared. This becomes plus 6x minus 1, so plus 5x minus 3 dx. And now I can integrate. We're going to add 1 here, so that becomes 2x cubed over 3 plus 5. Remember, there's a 1 here, so I'm going to add 1 x squared, but I'm going to divide by that new power as well, minus the 3. And remember, there is no x, so I'm going to add 1 to it. So this becomes minus 3x, and then don't forget your constant of integration. Now, remember, we have a special name for these. This is called an indefinite integral. You might remember from earlier, we talked about definite integrals last unit, where we can use a definite integral to find area. This is an indefinite integral because we don't know c. We don't know c1. In other words, this is saying this is not unique. Remember, there are lots of functions in this family of functions that will have this 2x squared plus 5x minus 3 as a derivative. They all just differ by a constant. So that's why we say it's not really unique. Now later on a few days, we are going to find c there. All right, I'm going to stop here now for this video, but if you go to my next video, I'm going to work about 3 more problems just from practice, okay? I'll see you then. Bye-bye.